All right, so welcome to lesson 2 of our unit on linear equations. Yesterday, last lesson, we looked at a equation for a line written in what we called slope-intercept form, which was y equals mx plus b, remembering that m was equal to the slope and b was equal to the y-intercept. Now, occasionally, we will do the opposite of what we did last lesson. Rather than having an equation and plotting a line from it, we'll be given a line and we'll have to figure out what the equation is. So in order to do that, the first thing that we try to do is we try to find the slope. Now, I mentioned to you in the last lesson that the slope of a line is equal to the rise of the line, how far it goes up and down, over the run of the line, how far it goes right or left. Now, rise, if you think of it in terms of the axes on the rectangular coordinate plane, that is the y dimension. And if you look at how much it moves to the right, or right and left, that is the x dimension. And from that, we can derive this formula, where slope, rise over run, is equal to y2 minus y1 over x2 minus x1. And those values, y2 and y1 and x2 and x1, they are the x and y values for two ordered pairs. So, in essence, we can get the slope of a line if we know at least two ordered pairs on that line, 2 points that exist on the line and the coordinates of those 2 points. So, as an example, if we have two ordered pairs like 4, 5, so I come over here and I go over 4 and I go up 5, and there's my 1 point. And the second one is 2 and 8, so that's the second one. And from that, I can plot a line. So I'm going to try to carefully draw through there, put arrowheads on that. And I can try to figure out what the slope of this line is. So let's take that formula. Slope is equal to y2 minus y1 over x2 minus x1. Well, what is this y1, y2, x1, x2 stuff? What does that really mean? Well, what it really means is the x and the y values from the first ordered pair and the x and the y values from the second ordered pair. Well, which one is first and which one is second? Well, really, that's up to you. It doesn't matter which one you choose. So if I write down those ordered pairs there, I'm going to look at these things and I'm going to decide for myself, I'm going to make this guy right here the x2, y2 ordered pair. And I'm doing that primarily because this y value of 8 is larger than the y value of 5 in the other ordered pair. So that gives me y2, so that's my 8. So that's 8 minus 5, that's the y1, or the y value from the other ordered pair, over 2 minus 4, and that gives me 3 over negative 2, which is equal to negative 3 halves. So the slope of this line is negative 3 over 2, remembering our slope-intercept form, negative 3 over 2x, and then I go plus. What is my y-intercept? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 11. So plus 11. And that would be the equation of this line we figured out by calculating the slope and looking at what the y-intercept is. Okay, so let's take a different example. Here's a second one. And let's figure out this one just so we can practice this. So one more time, slope is equal to y2 minus y1 over x2 minus x1. And in this case, like I said, it doesn't really matter. I'm going to make this guy here the x2, y2 ordered pair. And so that's going to be 4 minus a minus 5, and 4 minus a minus 3, which is equal to 4 plus 5, over 4 plus 3, which is equal to 9/7. So for this guy, the equation would be 9/7 x. And then in this case, it looks to me like the point that the line crosses the y-axis is at -1. So I go -1 for the y-intercept. All right, so let's move on. Sometimes we are given an equation of a line not written in slope-intercept form, so not written in the form y equals mx plus b. And when it's not written in slope-intercept form, it's often written in this form called standard form, where a and b and c are just numbers, whatever the numbers happen to be. So it could be something like this, 2x plus 5y equals 10. That is called standard form. Now remember the unit that we had where we converted formula around to solve for different variables? I could convert this thing into slope-intercept form if I wanted to, and then I could plot the equation the same way we did in the last lesson. But if we don't want to bother, or if it looks too complicated, we can plot a line written in standard form. And to do that, I'm going to do a couple of things. First off, I'm just going to go down here to my grid, and this is where I'm going to plot it in just a minute. And I'm going to make up my little table of values. And my table of values are going to come from these three things. They're going to come from the y-intercept, the x-intercept, and one more point. Well, what do I know about the y-intercept? When a line crosses the y-axis, what is the value of x? The value of x at that point is going to be 0 at the y-intercept. So I could take 0, plunk that in where I see the x, and I get this. This basically is 0, so I get 5y is equal to 10. Therefore, y is equal to 2. So I can come back down to my little grid here, and I can say for a value of x, y is equal to 2. Now, what do I know about the x-intercept? Well, that's the point where the line crosses the x-axis, and where it crosses the x-axis, the y value is 0. So I'm going to do the exact same thing. I'm going to say 2x plus 5 onto 0 is equal to 10. That is 0. So I get 2x is equal to 10. Therefore, x is equal to 5. And I can plunk those values in here. So when x is 5, y is 0. Now, I need one more point. I could do it just on these two, but if I've made a mistake, I'll never know. 3 points will always tell you if you've done it right, so I'm going to do a third point just so I'm smart. I'm going to take my formula, 2x plus 5y is equal to 10, and I'm going to pick any other value of x, any other value for x that I want to put into this table. And so to make the math nice, I'm going to do, oh, let's say 10. I'm going to say a value of x is equal to 10. So that's 2 onto 10 plus 5y is equal to 10. So 20 plus 5y is equal to 10. I'm going to get the y all by itself by subtracting 20 from both sides. I get 5y is equal to negative 10. Y is therefore equal to negative 2. So for an x value of 10, y is equal to negative 2. Let's see if I've done that right. So I come down here at 0, y is 2. At an x value of 5, y is 0. And at an x value of 10, y is negative 2. Now those do look like they're going to line up, and I'm going to try to carefully draw through here. There's my line. So 3 points, I know I'm correct if they all line up. If I've made a mistake, it'll be really obvious with 3 points. So I'll always do a third point. And for that third one, after you've done the y-intercept and the x-intercept, pick one that makes the math nice, right? I could have picked any value for x, but but it could end up giving me a really weird value for y. So pick something that makes the math nice and you'll be easier to figure it out. Okay, so I said earlier that my other option is I could convert this standard form into slope-intercept form, and that's just like we did in the other unit. So I need to get y all by itself, so I'll subtract 2x from both sides. So I get 5y is equal to negative 2x plus 10. Now I'm intentionally writing it in that order with the x first, because that's what my slope-intercept form is going to look like eventually. Now I need to divide both sides by 5, so I get those canceling out. Y is equal to negative 2x over 5 plus, and this 5 goes into 10 and leaves me with 2. So if I plot that, a y-intercept of 2 and a slope of negative 2/5, I go down 2 and over 5. And there's my 2 points, and I can draw a line between them. And do they look the same? Well, I can compare that one to that one, and yeah, they do look the same. I've got the same line. Okay, so I just want to talk about two special cases. Excuse me. Two special cases where we see lines drawn that are either purely horizontal or purely vertical. If we look at this line, you'll notice that if I extend it off into infinity in both directions, it is never going to touch the x-axis. It is totally parallel to the x-axis. I do have a y-intercept value, and that y-intercept value right here is at 4. The ordered pair for that would be 0 and 4. So if I go back to y equals mx plus b, I could say right away that my b is going to be 4. That's great. Well, what's my slope going to be? What's that m value going to be? Well, clearly if slope is equal to rise over run, is there any rise here? Well, no, actually there is no rise. There's absolutely no rise, which would be the equivalent of 0 rise. And in that case, it doesn't really matter what the run is, because 0 divided by anything is 0. So I'm going to plunk a 0 in there for my slope, and that leaves me with y is equal to, what is 0 times x? 0 times x is 0. Do I need to write down the 0 there? No. I end up with an equation of y equals 4 because that piece all basically goes away. So the equation of this line is equal to y equals 4. It has a 0 slope. Therefore, that whole first chunk, the mx portion of the slope-intercept form, goes away. All right, so let's take a look at a similar situation. I now have a line that is purely vertical. Is it going to touch the y-axis at all? It's parallel to the y-axis, so it actually won't touch the y-axis at all. So what does that mean for this b value? Well, it means that that p value is nothing. Can I say that it's 0? Would that be accurate? Well, that would mean that the line would cross the y-axis at y equals 0, which would be over here at the origin, but it doesn't go through there. So I can't even say that. I end up with a formula that looks very different, and I'm just going to cut to the chase here. Basically, in this case, x is equal to 4. That is the x-intercept value, because it's crossing the x-axis at 4. And there really is no other way to write this. There's a slope of this vertical line would be undefined. The horizontal line has a slope of 0 because there is 0 rise. Remember, it's rise over run. Well, in this case, the run is 0 because there is no movement side to side. And when you divide by 0, well, you can't divide by 0. It's undefined. So the end result is that for a pure vertical line, the formula for that line ends up being x equals 4. well, in this case, x equals 4, or x equals whatever point the line crosses the x-axis. Now, the last thing that I want to point out about both of these horizontal and vertical lines, if I had an x and a y table like I've had in other places, let's look at this guy here, y is equal to 4. Well, if I say, what is y going to be when x is 3? Well, y is 4. At 3 on the x-axis, y is 4. Well, what if it's like -7? Well, out here at -7, y is 4. What about 0? Well, y is 4. Y is 4 for every single possible value of x. If I look at this guy here, and I draw my little x and y table, and I say, well, what about when y is 0? Well, in this case, x is going to be 4. What about when y is -3? Well, x is 4. What about when y is 5? Well, x is 4. So again, x is 4 no matter what value of y we put in there for a vertical line. Okay, I hope those last two made sense. They're sort of unique situations. Just sort of tuck them away, make notes on them. And basically what you want to say to yourself is a horizontal line will have a formula y equal to whatever the y-intercept is, and a vertical line will have a formula x equals whatever the x-intercept is. Okay, so make notes on this. I will be checking. Please go back over whatever you've got, whatever time you have, make notes tonight, please. Do a good job. You will need these for the June exam. Please don't try to run just on your brain. Fraser, I know you've got an amazing head on your shoulders because, I mean, come on, you're Fraser, but it doesn't cut it. You need to make notes. Okay? Hope you guys enjoyed this. I will do another one tomorrow.